Welcome to Lights Out. I'm John Weiss.
I'm Andy Henderson.
And today we've got Christine Andrews joining us to talk about discrete and process manufacturing. Hey, Christine, thanks so much for joining us.
Hey, my pleasure. Thanks for inviting me.
Yeah, we're happy to have you. Can you tell us and the folks a little bit about yourself? Who are you?
I started my career a couple decades ago, and actually got a degree in chemical engineering, ended up going into process engineering. So it's interesting I'm in the space I am now, because actually the majority of my career, I was really, I would say, more in the field or shop floor, working alongside maintenance personnel, operations, production managers, really at the plant level, helping to drive, really asset performance management. It was APM before, digitalized APM solutions in the chemical space predominantly. Spent a lot of time in process manufacturing. Then I made the segue into the digital technology side, roughly around 5-6 years ago.
That's awesome. Really diverse, and most of your career has been spent working either in an industrial setting or for an industrial company, which is why I thought you were a really great guest to have on. And more importantly, we just recently had a discussion, Andy, like a week ago. Christine and I were talking about process manufacturing and discrete manufacturers and just what that looks like today, what's happening in the field. And so I thought that's a great topic to come talk about here. So maybe a good way to kick it off, Christine, if you could help educate us and the listeners a little bit about discrete and process manufacturing. What does that mean? How are they different? And we can kind of go from there.
Discrete's typically serialized products that can be disassembled, if you will, or broken down into their component and their constituent parts. And process manufacturing, you're taking raw materials and transforming them. So you can't break down really bread into its constituent ingredients.
What are you seeing between the two, discrete manufacturers, process manufacturers today in the industry? Are folks after the same things? Meaning, I know a lot of people care about quality, of course, and efficiencies, but generally speaking, do these types of processes or manufacturing approaches care about the same things, or do they have different interests typically?
Well, I think that's a really, really good question, because all of them care about cost and efficiency. I don't care who you talk to, right? And safety and compliance, right? Every manufacturer out there cares about those things. We don't want accidents, right? We don't want any violations, but what those things mean and how they're managed are very, very different. And the priority in terms of like quality, cost, and efficiency are important to all of them, but how you manage quality and the production of a discrete product with a complex bill of materials versus how I manage quality if I am producing a fluid or a batch is very different. In one case, I can manage quality stepwise, sequentially throughout the process as the build progresses. In the other, I really have to build quality into that process itself, because I'm not able to check it until it's finished, essentially, right? So that means that in one case, I am really designing, when you think of like, to use quality, right, to continue that one, I guess, with discrete, I think of it as you have to build in those quality, those requirements and those stage gates, right, as part of your process and your product design. Because there's the product design, there's your process design. Whereas in process manufacturing, a lot of that is going to be governed right by the processes themselves, and it requires there's latitude, if you will, given. I think there's more latitude in the process manufacturing for what's happening on the manufacturing floor. Somebody once told me, and I think it was a good point, when you go to a discrete manufacturer, a Boeing, right, or a Ford, where are the majority of your engineers? They're in design. You've got CAD engineers, simulation, and engineers and designers. And when you go to a chemical manufacturer, a Dow or DuPont, if you will, you're going to find a lot of those engineers are on the manufacturing side, your process engineers, your production engineers, manufacturing engineers. So that's kind of the different. I wouldn't say either one of them deprioritizes quality. It's where quality is really good. What is governing quality? Is it at the design stage, or is it really based on a lot of possible random variables or ambient conditions in the manufacturing set?
Even in the manufacture of a discrete part, like the car, for example. There's going to be a process manufacturing step, like in the smelting of the metal and the casting of the raw components. So it's not like every step of the automotive manufacture of the manufacturing of discrete products is purely discrete. It's largely, I think that if taking what you're saying, this it's largely when you get towards the end and you're doing the assembling, that's when it really becomes what we tend to think of as discrete manufacturing. Is that fair?
Yeah, I think cars are an excellent example because you just brought up, since you brought them up, paint. Think of paint booth,
Yeah.
the application. Yeah.
Yeah.
I mean, it's a classic process that it's not discrete, it's usually in batches, and it's very much governed the same sort of quality paradigms that govern process manufacturing absolutely govern those paint booths as well.
Yeah, good one.
So it's interesting to me just listening because of course my brain, I'm always thinking about what does this mean for technology and adoption of technology? And what I'm hearing, I would assume that these types of manufacturers probably use technology very differently, because if I'm building a car and let's say I'm using a die stamp process to make the hood of a car. So I've got a piece of sheet metal and it's going to go through a series of stamps, big industrial stamps, if you could picture that. And then at the end, you've got, your Mustang hood, your Corvette hood, and it's perfectly shaped to fit the body of the car, right? Um, it's probably very easy, and I say that very loosely, right? Because nothing in this business is really easy, but it's probably easy for a discrete process like that to use something like computer vision or video analytics at each stage of the stamp to make sure that in a multi-stamp process, hey, everything looks good along the way. And then at the end, okay, we've analyzed every single stamp, and we're pretty confident we've now produced a pretty good hood for this car, versus a process where maybe we're making a pharmaceutical and there's all kinds of chemicals that are being mixed in a big vat somewhere. There's really no way to test a quality of that until it's finished, right? And then you can go through some genealogy if you have a problem and figure out maybe where that problem occurred. But you can't really stop the batch or the mix process just to determine, oh yeah, it looks like we're trending in the right direction for this pharmaceutical. So I guess just thinking out loud, right? But the way people are adopting technology in this example, this is quality that we're talking about. And it's a means to the same end to ensure it's good quality. But I think the application is probably very different. Would you agree with that?
Yeah, I would. And in fact, continuing even further, since we're talking about quality, think about it too from a tracking perspective, right? You can track on a serialized car. I can track down to the car and all the components that went into the car. I have that a level of granularity and visibility. But really, if I'm making, I don't care if it's food, beverage, to your, pharmaceuticals, I'm tracking down to a lot level, right? And the individual units and all at one point, I have a batch and I have an agglomeration of different raw materials. So getting down to that level of traceability of this pill was, yes, you can have visibility, and that's why it's kind of complex, right? When you talk about the genealogy and the track and trace capabilities for a process manufacturer versus a discrete. I think it's some cases, yeah, it can be a different level of challenge, right? Because you have heels and tanks if I'm drawing raw materials out of some silo, right? And so what constitutes, was it really this lot or was it a mixture of lots, that produced this final good? So it gets a little bit more, I think, nuanced, right? As opposed to individual components. When you talk about technology, I think that there's two things. There are different, like I said, they all want to drive costs. It's just, what does that mean? What drives my costs? And I used to think about it too in terms of complexity, right? If I have a diverse range of SKUs, what's more important to me if I have a limited number of SKUs, right? What's more difficult to manage? Well, SKU mixture means it's more difficult. And now I'm extending it, actually going from just discrete, but to within process as well, right? You have different levels of prioritization. If I'm doing a high volume, low SKU diversity, more commoditized product versus high SKU diversity and lower volume, where I have smaller batch sizes, there's different priorities there. And because it's more difficult to manage all the processes that go with the high, so it's more process centric with the high SKU mixture, as opposed to if I have high volume and low SKU diversity, I'm going to probably have really, really large tanks. So asset management becomes really critical at that point. And I probably don't have that much opportunistic downtime, but you can kind of continue that, right, and extend that even into discrete manufacturing as well. So it's really about what's my greatest challenge. And if I'm designing an airplane, my greatest challenge is, right, the design. I need to make sure that I mean, there's so many different components, and managing that BOM complexity is huge. And if I'm making bread or pharmaceuticals or whatever it is, then it's really not, I've got a recipe, but it doesn't have that level of complexity, but it does have a high degree of dependency on environmental conditions and things I can't even really design and simulate for in the lab.
So a lot of stuff that you can't control, right? At the end of the day, you can't control, to some extent, you cannot control temperature variations or humidity in certain parts of an operation, or even within an asset. To Andy's point, you might have hot spots or cold spots in an oven, and you may not really know that until you pull your product out, right? And this all points to what I would imagine would be a trend in the industry around more advanced monitoring and diagnostics capabilities when it comes to instrumentation. Are you seeing that in the market? Are companies interested in outfitting ovens and different parts of their processes with let's call it connected sensors or things like that, so that they can collect more of this information that we're talking about?
Yeah, no, that's a good point. So there's two components to that, and it kind of gets back into some of the nuances of discrete versus process anyway. And that is, I'm seeing one, yes, more sensors, so we need more data. But I also hear a lot of people saying, well, wait, what can I do with simulation, right? What can I do with soft sensors or virtual sensors? So for example, if we're going to use ovens, a good example, and primary metals, ladle furnace is a really good example. And that is, there can be environments where right now, technology may not exist to support the sensorization, particularly in like an environment like a ladle furnace, which is a pretty harsh environment. And then the question is, okay, so how can I know what's going on? And that's where there's a combination of all the data I've got on my process that can pinpoint, wow, when I have, so what I'm seeing is both the need for sensors, but more or less, how can I sensor around these really high critical, perhaps bottleneck operations? And then can I also leverage things like simulation, where I can then say, okay, I identified a problem or a potential issue here under these inputs, and then I get these outputs. Now, how can we emulate or virtually represent what's happening within that asset itself to identify opportunities for improvement as well as fixes, right? How to address the problem, not just that I have a problem, but how do I actually solve the problem? So I see kind of a combination of both. And I think that personally, what I'm seeing is in discrete, there's more of an emphasis. I think I'm going to make a blanket statement here. I apologize for that. But as a generalization, and again, this is a broad generalization, I think discrete manufacturers are not necessarily, again, generalization, as mature in data collection as process manufacturing. Process manufacturing, particularly continuous, have been collecting a lot of data for a pretty long period of time. And they typically also have a slightly more mature maintenance culture. Whereas in discrete, a lot of times, maintenance may be done by the line operator himself. So kind of with that said, what I see in discrete is more of an emphasis on, okay, let's get data and a little bit more on the sensorization aspects. I see in process, it's all, which is funny, I guess, when you think about it, because in process, I see more of an emphasis on how can we utilize some of these classically discrete tools, like for simulation and design, how can we apply that and make our jobs easier, make our processes more efficient, improve our quality, and better understand how to fix problems. And I think it's interesting. I see both of them as like design tools that have classically been used in simulation tools in Discrete. I see them, process trying to utilize those more. And I see conversely, the kind of really data-centric, data-driven approach of process. I see that discrete manufacturers are really looking to leverage that more and more. So it's kind of interesting from that standpoint. I'd see them both trying to learn from the successes of kind of those other verticals and those other markets.
So when those process guys are using like simulations and trying to infer, call it states that they can't measure directly, do you see anybody doing that in real time, like running those simulations, inferring those states in real time? Or is it generally like I think what you said was a problem was identified and we know the inputs and outputs, and then we try to figure out using the simulation tools like what could have happened in the midst of that. Is that the primary use case today, or do you see them doing the real time?
I think they're trying to apply the real time, but I do see it used a lot for connecting, like developing a formula, designing, coming up with the recipe, the formula, developing that. How do I scale that up successfully from a pilot or from a small batch to big batch type of thing? So I do see it being applied there. Now that's kind of a one-off, but a lot of those those classical physics based, which, I mean, you got all of three of us are probably familiar with that term, physics driven modeling versus data driven models, data driven being more the machine learning, AI side of things, and physics based, those empirical correlations. I see that those are typically used for either scale up, and they typically, or troubleshooting, are a lot more computationally intensive. So they typically don't run in real time. And yet, so to your point, which I think is where you were going with it, there's a desire to do that or figure out how do we leverage the best, like physics guided neural networks, right? How do we leverage the best of both worlds? I mean, that's a term that I've been hearing more and more about. So really, merging that data and physics world.
Yeah, I come from I started my career doing internal combustion engine testing and validation, and there's always this. We'd love to have more sensors on the engine in order to know in better detail what's happening for all the different components of that engine. But there's a cost associated with it, especially when you're talking about mass producing the engine. Pennies can have a big impact, and so there's always been this notion of let's try and use physics-based modeling to infer what's happening at, say, in-cylinder pressures, right? To infer what's happening in the in-cylinder pressure so that we can better control that engine, better control emissions and so forth. So you take temperatures and things from various parts of the engine, and inside of the engine control, it's trying to run those models in real time and use. And so there's the evolution over time is more and more of that, to be able to do it in closer to real time.
And great content here. So we talked a little bit about the difference between discrete and process, and who's adopting what and who's using different types of tech. I think that's been really insightful, at least for me. I've been so quiet because I'm actually soaking a lot of it up like a sponge. So thank you both for educating me. One thing to me that was really interesting that you mentioned, Christine, and I'm not so sure I ever really thought of it so clearly, the delineation between the maturity between process and discrete, where it's kind of second nature. You go into a process manufacturer, you expect there to be historians that are big databases that are collecting super fast data sets coming off of the whole line, and then it's also kind of second nature where you go into a machine shop or an OEM machine builder or somebody that's real traditional discrete manufacturing, and you're going in with the mindset of, all right, how are we going to instrument this device to start collecting something? And I'm not so sure I ever thought of it quite in the sense of the difference between the two and the maturity between the two types of manufacturing that's out there. So one thing that's interesting to me in that same light, and as we wrap here, thinking about the future and between discrete and process, who do you both think is going to be the let's say the more aggressive adopter of new technologies when we think about machine learning and AR, VR, and all of the fun stuff that we like to talk about? Is it going to happen in discrete faster? Is it going to happen in process faster? And what do you think that's going to look like over the next couple of years?
I think that's a question. I'm not sure I would break it down to discrete versus process as I would industry or vertical leaders versus laggards. Not, not mean it in a disparaging way. When you talk about where the value is going to be driven, remote troubleshooting and support using AR, VR is going to deliver a heck of a lot more value if I don't have a lot of opportunistic downtime as it is. If downtime is, millions of dollars every 15 minutes versus thousands of dollars every 15 minutes, right? That becomes that's going to drive adoption one way or the other. And then that would be just one of the examples. And I think IoT, whether IoT is new or not depends on your definition, right, of it. But IoT for a smart connected product and closing the loop on design is of course going to be huge and discrete. If I'm an OEM, if I'm a machine builder, I want to get as much data off of that vehicle, off of that heavy equipment as I can. And I think that delivers a lot more value.
Yeah, I think John called us both out, but I was going to say something similar around, I think it's use case specific, right? Where the technologies, because I think the example you give around AR, VR being used for remote diagnostics or bringing an expert into the situation. I think that's a really good use case, and you could probably find one of those no matter whether it's discrete, process, whatever. And then as you're talking, I was thinking the one thing that I think is going to be pervasive, and I believe you said the same thing, is data, right? Data is going to be important no matter who you are, where you are, what's going on. The differences are going to be in how that data becomes interpreted at the end.
Really appreciate the time, Christine. Thanks so much for joining us.
Thanks again for having me.
It was a pleasure. Thanks.
Yeah. It's always a blast. So we will, I'm sure we will be knocking on your door again for you to join us here in the future. Always really valuable insights. So thank you. And to all of our listeners and viewers, if you're watching us on YouTube, don't forget to like and subscribe, and we will see you next time. Thanks so much.